Welcome. It's a small but hardcore crowd I can see here today. So thank you for joining my talk. I know it's a talk about legacy, so maybe that's why it's a hardcore crowd. My talk is called Using Kubernetes for Operating Legacy, and the idea about it is that we have some legacy and we still want developers to be able to work with it. And that's what the talk about. My name is Soren. It's pronounced with a Danish Ø. So I'm a software developer at the platform team at Bankdata in Denmark. I'm a software developer at heart, but in a platform team. We are kind of platform engineers. So in Bankdata, the platform, it has a kind of broad meaning more than just running some Kubernetes clusters, but we will see that. So let's get started. So first, I'm from Bankdata, and probably nobody knows Bankdata outside of India because it's a local banking association. So it's an association owned by these 8 banks. 2 of the banks are the second and third largest bank in Denmark, but still, in the Indian context, it probably doesn't mean we don't have billions of. We don't have what is it? SBI has 300 million customers. In our context, every third person in Denmark, they are customer in these banks. So that is the 30% of Danes that bank with us. It's an association, so that means the banks, they are the owners. And we basically do any kind of IT work for them. I'm doing software development, but there's also running ATMs and all kinds of data lakes, whatever the banks may need, PCs in their branches and so on. Oops. From the software perspective, we have 3 main things we run for them. That is some portals, and they are the net banking for people and home pages for the banks. There's for the counselors, bank counselors sitting in the bank branches when they talk to customers. There's an internal system, and there's a mobile application also for net banking. I put a timeline about history because I'm going to talk about legacy today. So as you can see, Bankdata, they started all the way back in 1960, and that was of course not with computers, but already in the 70s they started to have online access and so on. And in the 2000, that is what we are going to look at, the kind of legacy we are going to look at today, and all the way up to today, of course. Let's go a little forward. So when I talk about development at Bankdata today, almost all development is on Kubernetes. Most services that are built in Java, I guess it's like that in all banks and enterprises, they like Java. We're using a mix of Spring Boot and Quarkus for our services. It depends on the teams. There are you can say there are factions who prefer one of another, but from my platform team kind of view, we don't really care. It's just some application. There are about 1,500 unique services to run the services that Bankdata provides. So we run those in Kubernetes clusters, and they are kind of small compared to, again, what we have heard here about today, because even though it's 1,500, they don't have to service that many customers. We know the number of people are kind of limited in Denmark. We think we have a kind of modern setup with Java, maybe a little enterprisey, but we use Git and GitOps and so on, and Kubernetes, and we have many. We use many of the normal modern Kubernetes operators. So that is what they mostly do today. But we also operate 3 large multi-node. It's called HCL Digital Experience. It's a portal server installation. It was called IBM WebSphere before. Maybe some of you know about that. And those there are still, even though it's I said they started in around year 2000. they're still critical for the workings of the banks. So I wrote here that the daily driver for the bank employees, the counselors in the banks, that is their main work. Every day they log into this portal and they service the customers. The bank's homepages, websites that are customer and net-facing, they're actually also running on these portal servers somewhere inside. There's of course some layers like Cloudflare or whatever in front of it, so you don't go directly to them, but the pages are somehow at some level served by a portal server. Then we have the business banking customers. There's 180,000 of them. They are also using applications developed on this portal server technology. I put them in here that of course there are developers that are working on these portal systems because they has to be maintained and patched, and I mean, we are like any bank, we are very regulated, so we need to ensure that our software is up to date by patching and so on, otherwise we will get audited. So all the new developers, it's very hard to get them to work with the legacy systems. They all look to what the other developers can do on Kubernetes. So that is setting the context. So some of you may be sitting here and thinking, what is a portal server? I already brought you a little back to the past. So it's something they started around after year 2000. It was a new technology. I guess all the architects and people who worked on the year 2000 problem, they got lazy and then they thought we have to invent something new, complicated. And then they came up with the portal server. Here's a small introduction what it is. So in the portal server you run something called portlets, and they are basically Java web applications. They adhere to a framework, so there are specific things you can do in them. You have to define the views and so on, how it is in a way that's conformant to this framework. There are some web page definitions. You may see there that you can compose the portlets into a single page. More portlets, and you can define the layouts and content, static content of the pages. And again, as part of this portal server, also we have some traditional Java EE resources. So again, if you have little history, you probably know that some few years back that was the top of the line. Everybody wanted to do Java. How we are running it, on the right side here we see that the nodes I look at the bottom, that is the portal servers. Portal servers, it's a JVM, a large JVM with a lot of applications inside. How do you scale it up? We don't scale it up, we scale it out by running more instances beside each other. It's nothing new in this. As I'm saying, they have been doing the same since almost 20 years now. So in this setup, they have shared storage. When I say storage, I don't mean just file storage. It's also database storage, for example. So they share all these instances, nodes, they look at the same at the bottom. On top of it, there's some HTTP proxies that kind of, they rewrite rules and everything, but they're kind of bound to how the portal servers work. And on top, of course, we have an external load balancer facing the internet or the internal network. If we imagine some customer coming, because this setup, users, they will always be directed to the same active node. So moving, if the node dies, then you will have to log in again. That's just how it is in this setup. At some point, as I said, this setup, it has been running for nearly 20 years. And I'm in a platform team. Somebody came and said, isn't this like a platform? Why don't you run these portal servers? It's probably somebody. It is definitely somebody from management who thought that, or had that thought, because we would like to just work on the Kubernetes. But anyway, it became platform. As part of our taking it into the team, we decided we want to move this to run on Kubernetes. At the same time, we thought about how can we make a better developer experience for this. Because in the old setup, I didn't take any slides here, but you can imagine it's something about change management, logging into mainframe black pages on mainframe and making changes and so on, and moving things around. So it was also something that was designed 20 years ago. We want to reap the benefits of a modern Kubernetes developer experience just for this type of platform. So as is, that there's more developer insight into what is actually running in the portal, because they can press a deploy button, but then they don't know actually what happens. It's in production systems, we can't allow them to do that because it's customer data, and that was just how it was. The developer experience also, these people are not only developers for the portal servers, they're also developers on Kubernetes, so they have kind of this extra cognitive load that, okay, they want to develop on the modern, but they still have to think about how do we develop these portals. And it was very different from their normal workflow. One last point I put that is that the development options for this running on servers and so on, sometimes they need a local environment only for themselves when they sit and develop on it, and that was not very easy. We made something about, we installed the portal in a Windows version, and we made a 20 gigabyte zip file they could download and so on, but it was not a good experience. So we took inspiration. I mean, there are other existing CNCF projects that work with Kubernetes and how to manage external resources. So, for example, crossplane, that's one thing that comes to mind. It's not the same, but it's kind of the idea that something living outside of Kubernetes, you can also use Kubernetes to operate then. Yes. And then the question, can we do it? And of course, yes, we can do it. Otherwise, I would not be having the talk today. And how do we do it? It's controllers. Lots of controllers. Every time we see some problem that we need to, some problem with operating some part, then our solution is it has always been to create a controller for it, to do it. I listed a small list of the existing controllers here. So we have we call it an environment controller, and the idea is that it's a controller that can spin up a portal server with the configured and ready to use. Inside this specific controller, it's not very advanced. It builds on Helm and Ansible. So there's a Helm part that spins up the pods, the Kubernetes parts, and then there's an Ansible part that connects into the running pods and do the configuration. What we call a deployment controller, and that is about managing these portal resources inside the portal. We have test environment controller, as I said before, developers, they want to develop, so we create a controller that can spin up this type of temporary environment for them with all the outside necessary connections to the backends and so on. We create a restart controller. It turns out restarting this type of portal server, it's not as easy as pressing the Kubernetes rollout button. They need to be there are some pre-steps that need to be done to shut them down in a proper way. They have to be restarted in a specific order, the pods, and afterwards we have to do some post process to make them join again. The setup. As a login controller, again, it's an old application. We are just putting it into Kubernetes and running it. So it does not conform to the standard outlogging and so on. So what do? We create some controller that can connect and collect the logs and put it into the centralized logging management. Backend controller, that's just another controller. So again, there's some state in this portal that has to be there for all the applications in the portal to work correctly. And what do? We look at the existing logic. We create a controller that mimics it and just puts it into the existing one. So it's state metrics. We know from Kubernetes there's the kube state metrics where it collects all the resources, Kubernetes resources, and exposes them as Prometheus and again, we created some state metrics for all the portal resources where we had created new custom resources for. Controllers, you say, it's not this type of controllers. So when we looked at the controllers, we thought it's controllers we need. So all these controllers, they have some properties, and main thing is that we have a specification, what should it be like, the resource, and the status of how is it done, and that is kept inside the Kubernetes resource. That's the actual resource inside the portal. That's the implementation, we can say, of the Kubernetes specification. This model, we like it for some, there are different types of models. We like this model because it's very simple to think about it. If you think about a state machines, they are, it's like you have to know what is the exact state, what are the edges, how can you go to the next state, and so on. Here, it's what we call level triggered. Level triggered means we look at the complete resource and the complete status, and then based on that, can we level up? That's what the reconciliation loop does. It kind of levels up to a final ready state. It's resilient. We can restart these deployment loops how we want, because it will always just pick up from the last known state. The last point about the 10%, that means that at any time we can rerun the steps without any, that is kind of the reconciliation that has to implement that. So in order for the model to work. There are great frameworks available already. Controller runtime, if any of you have created controllers, you probably have used that. It's part of the Kube operator SDK. There's the Java operators SDK. I said before, we are a Java shop, so that's what we used. But basically any language you like, there's Kube for Rust, and there's something called Copper for Python. They all implement this type of controller logic that you can just take down and start using it. I think I have said most about this. The desired portal resource, that is just the Kubernetes description. Actual resource, that is what we say, it's provisioned inside the portal. As some examples of this resource, for example, a portlet we have shown before. There's also data source. Data source is like a configuration of how to connect to a database. If you know JE, probably you know all these secrets inside Kubernetes. We have a secret, but inside the portal server, the same kind of implementation, a different kind, is in queues and so on. Important is that one of these portal installations, it consists about 2,000 portal resources. That's not many, you can say it's some, but we have to think about that. If we have just one portal running, that's not bad, but we have maybe in a cluster we can have maybe 10 of these portals running, and then suddenly the number of resources that needs to be reconciled, it grows. This is a little bit more about this controller, how does it work. So there's the Kubernetes resource, and there's a source event handler that listens or watches the Kubernetes resources. If it sees any change, it adds it to the work queue. And there's the controller will then look at the work queue. If there are more events on the same, it will kind of deduplicate them. Once it goes through the queue and it's ready, there's a worker ready to actually do the reconciliation, then the controller will also make sure that a resource is only reconciled one time concurrently. So that it can't, there are not two workers that can work on the same resource. Different versions of the same resource. Also, it will periodically reconcile all the resources. So just in case it gets it kind of gets out of state somewhere, then it's like a fail-safe. It will also reconcile our resources at startup. And finally, many of these controllers, they have a caching of resources just to make it fast, so it don't need to interact so much with the Kubernetes API. At the right side, we see there's a portal resource. So that's the final thing. Once it has been, that's what the reconciliation loop does. It somehow interacts with the portal and updates the actual resource. I have an example here of the deployment controller. Let's just go through it. At the left side, we have we keep all our configuration in Git. So we have a Git repository that defines the resources, the Kubernetes resources that are needed for this portal. A developer can directly interact with this configuration if they wish to. They can also use the pipelines and tooling around it, and we have put an API on top of the Git just to get around of this concurrent update of Git problem. Then we have a typical ArgoCD that takes the configurations from Git and put it into the cluster. In this example, then we have two namespaces, portal A and portal B. Each one contains one, it describes one portal. In the case of portal A, it's a portal that runs outside of Kubernetes, but in the case of portal B, it's a portal that runs inside Kubernetes. I'm just putting a single node here in there, but you can imagine there can be any number of nodes depending on what, if it's a small developer, then there's just a single node. If it's a production, then maybe there are 15 or something. So the deployment controller, it watches these resources and it updates into the portal like we saw before. The state metrics, it watches and it exposes the metrics to Prometheus so developers can get an insight. Yes, a little more about it. So just to sum up what we learned up to now, we said we want to solve a problem for the developers, and now actually we have solved that problem for the developers. They use Git like they do in their normal Kubernetes development. They don't really care about what portal. Is it a portal running inside Kubernetes, outside? It's not their portal. They're concerned about the portal resources that they own, and they will get the status of these resources either by looking at the Kubernetes resources or by looking at the state metrics. They don't need to go into the portal itself. It's just an example of some resources here we have. So how do you reconcile from into a portal? You can see there are different things that needs to be done, but an overall theme, I think we can call it, that is calling some scripts inside a portal node. And that is how this portal server, it works, that you call these scripts for updating different types of resources inside the portal. Typically the scripts, these shell scripts, they need some scripts themselves. For example, for the first one, WS, WebSphere admin, it needs to have a Python script. So in order to update in portal, you give it a Python script and it will do the connect to the portal API and get it done. Updates into the portal, unfortunately, they are serial and synchronous. That means you can only call one script at a time because the state in the portal is shared. It only allows to make one modification at a time. And asynchronous means that you have to call the script and you have to wait for it to complete. If you do not wait, then it will just simply roll it back. And another problem, some of these updates, they can take up to 1 minute. Just in actual updates, it depends how does it run. We can do it by SSH to an external one and call the scripts, or just kubectl x kind of from the API. So 1 minute, that sounds like a long time. I don't know if you have any reconciliations that takes one minute. So when you construct a controller now, what is the best practice? And that is just to reconcile. Reconcile every time there's a change, you reconcile, you read the complete state, and you decide what are the things that has to be done. Here's just some code from our deployment controller. We read the state in the portal, and that is one of the things that takes time, and we check if it needs the update, and if it needs, then we will push the update out in the portal. So if we remember the picture before about the work queue, that you can imagine that this work queue, when the controller after starting up, but also if there's this reconciliation event, then the queue, it will be full. It will have a lot of items to process, and if each item takes 1 minute, and we had 2,000 items, then up to 1 minute. And while this happens, we have a developer, he just made a new feature, and he's sitting and, where is my feature? So that it's not this best practice pattern, it did not work in practice for us. We did a quick test it's called observed generation pattern. That's something this Java operator framework supports, and it's also part of the Kubernetes today, that on the status field you put an observed generation field that once you are done reconciliation, then you update the observed generation. So the next time the reconciliation starts, if there's no change, if the generation in the metadata is not changed, then you can simply skip it. Does it work? It has that drawback that you have to trust that there's no changes inside the actual portal, because you don't check it at all. You just check the status in the resource. You use the Kubernetes resource as kind of a cache for what is there. So I say it's okay in production, because in production we don't give developers access to actually go and change things themselves. So if something changes, then it has to be a system change, and that doesn't happen that often. So it's okay. In development, developers can log in the portal and do modifications. So there, it's not a good idea. Yeah. So there's another pattern then for how to resolve this. So one is called the external state pattern. So in the external state pattern, we kind of divide the reconciliation loop in two parts. When a new portal resource is created, here it's a portal resource, but any kind of resource that uses that pattern basically. But a new portal resource is created. At the same time, the controller will create a config map, for example, a config map, another resource to hold the state. We use a config map. The config map is set with an owner reference to this portal resource. So, and then the deployment controller will watch both of them. So it will receive events for both of these two resources instead of only the portal resource. As a second process here on the right, the deployment observer that then does the part about reading the state inside the portal server, and once the state updates and it updates to the state, then it will update the config map. And because the controller watches it and it knows the relationship between the config map and the portal resource, it will then trigger reconciliation for the portal resource. And finally, it will do the update. We can see that when at startup, there's no change by the deployment observer. So the config map is the same as last time, meaning these periodic reconciliations, they will run fast. They don't need to go to the... In our case, the observer and the controller, they are in one big application, but that's just our implementation of it. Yes, let's look a little into it. So here we have the config map, and it has some data. As we know, when is it triggered, when is an event generated? It's only generated when the spec is updated. So we have to, when the data is updated here, then the event is fired and the deployment controller gets it. And finally, it changes, then we can read the actual resource, the portal resource, and we can compare it with the state that was just updated in the config map, and we can decide, do we need to do something? Yes, so that resolves the problem about startup. Right. I will just mention that we had some, basically this is what has to be done for us to reconcile these external resources, so that kind of sums up that part about it. I put a bonus slide in here because I practice my presentation always I take a few minutes too little. So I talked in one of the previous slides about we want to improve the developer experience also about these local environments. And for that we created the test environment controller that I just want to quickly mention here because we use the Velero backup. So before we had to get the full portal states, the storage out of, we had to draw it out of the portal, save it somewhere externally, and then they had to take it down and install it. Using Velero and Kubernetes volume snapshots, we can, it's like a snapshot to actually do it. So this time to create a test environment and update it. The problem is they need to update it all the time so it's consistent with the actual environment. They can do that in a few minutes now before it would take hours. So the key takeaways here from my talk today. So definitely you can do it. Every time our approach is that we need to know the application that we want to wrap. We need to know the APIs around it, and we need to we create a controller every time it is, and we need to know about how to design controllers to handle the situations about external resources that are sometimes not easy to get. From the developer side, our developers, they are easy access to the applications today now, so, and is familiar with them. So, as I said, there are generally less cognitive load that gives happy developers. So they don't have to break so much out of that now they're not working with Kubernetes anymore. They don't have to remember that now they have to go other places to look for status and so on. Their known workflow with Git and ArgoCD, everything is the same thing for them. Last thing, they have a much faster feedback loop because how we optimized it. Thank you. And I just mentioned very little today, but actually it's a part of a big setup, right, with a lot of technologies that, a lot of good open source projects that we have already heard about here today. So I saw other slides with, for example, we have something called Automation Highway. Is our way of managing environments through pipelines and all that part that is kind of good practice for it. I want to especially mention the development today we use for this. Most of our controllers, we use Quarkus, and in the Quarkiverse, there's a operator plugin that wraps this Java operator SDK. So it's very, very simple to get started with an application that where you get all the metrics, everything out of it. It builds on the Fabric 8 Kubernetes library and the Java operator SDK. So thanks to all these great projects. That's all that I had today. If any questions, then let me know. Q&A session will start. Thanks.
Actually, I have one question with respect to the reconciliation that you were talking about. So in the reconciliation process, isn't it better to use the Helm charts to generate a unique image ID or any hash based on certain variables and just compare that in order to reconcile rather than compare so many different variables?
It's I think what you are saying, that was basically the second option about the observed generation. That mean you are talking about that we keep the portal state inside the Kubernetes status resource. So, and that is a good approach. It's very fast, but it has the problem about the drift of the portal, if the portal drifts from what we know in Kubernetes. So at some point we need to still make the full reconciliation, and we could do that less often, and then use the cached version for most of the time. That is another option. Oh, you are right. Yes. No more questions, then let us say thanks for today. There's one question out.
I have a question.
Let me hear
So can you move back to the slide which was deployment controller?
Sorry?
The slide named deployment controller.
Let me see if I can. This one?
Yeah, this one.
Yes.
So you mentioned about portal B portal B node being inside the cluster and portal A being outside the cluster. So is portal A your legacy deployment, which is on bare metal, I imagine, or on premises?
It's all on premises.
Okay.
I mean, that's it's something we are looking into, because we do not once we are operating it inside Kubernetes, we are looking into some hybrid cloud options where we can scale it out to, I mean, in banks, if any of you are in banks, typically the end of the month, people need to check if salary came, and the first they need to pay their bills. So we have huge peaks on those 2 days, and the rest of the month we could easily run on a scaled down version.
Sure. So portal A node is running on physical hardware, virtual machines.
Yes, it's running on, it's virtualized hardware, but still it's static hardware. We cannot easily scale it up.
Got it. And the portal B node, they are running on Kubernetes clusters that you also maintain on premises?
Yes, also on premises.
Understood. So your developers have to only be aware of Kubernetes concepts and constructs.
Yes.
Yeah. And your deployment controller controls whether the deployment will happen on the physical hardware portal A
Yes.
or portal B in Kubernetes.
Yes.
Understood.
So,
Thanks, Soren.
welcome. I'll let- sorry.
Kubernetes distribution.
Oh, yeah, we are a bank, so we're using OpenShift's distribution. So everything that says IBM now, they bought Red Hat, right? So, sorry. Yeah. But we are looking at different options for the cloud when we want to go hybrid, because the
Wanting to move to let's say cloud. So in that case, will we be leveraging the cloud services like EKS, AKS, or there as well you would like to have?
we are looking at all options there. Recently, OpenShift, it's also available in public clouds. So, but yeah, we are just looking at options, what to do. I mean, it's for us, it's mostly a regulation problem about what we can move to cloud, and probably these applications, they will not be among the first that will go. So, because they contain a lot of customer information, all of them. Yeah. Any last questions on the edge? Should we say that's it? Okay, thank you all for coming.